program. Once again, a hearty welcome to our today's expert member, Dr. C. Mohanraj, Computer Vision Software Architect, Applied Materials India Private Limited. Hearty welcome to you, sir. Now I invite our department coordinator, Dr. V. Satish Kumar, sir, to give an introduction about our speaker, Dr. C. Mohanraj. Over to VSK, sir.
Thank you, ma'am. So it gives me immense pleasure in welcoming Dr. V. Mohanraj, software architect from Applied Materials. So he is an experienced AI/ML delivery lead with over 12 plus years of experience in machine learning, deep learning, and computer vision. So proven expertise in leading AI/ML initiatives and developing advanced AI-driven solutions, extensive experience in research and development with a PhD in computer vision, deep learning, and machine learning. So recognized with multiple awards for research excellence and paper presentation. So it's a great privilege to have you, Dr. V. Mohanraj. So now you can start the session. Thank you.
Thank you, sir. Let me share my screen. Hope my screen is visible.
Yeah.
Okay. Good afternoon, everyone. So, what I'm planning for this 1 hour session, 1.5 hour session, I'm going to talk about deep learning for computer vision. And part of my career experience, I worked on automotive industry and finance domain, and then I worked in the service industry. And a few of my research work as part of my PhD. So I have a couple of demos as well, which uses the computer vision for the deep learning. First, let me give a brief, just intro about what is computer vision and how we are trying to solve various computer vision problem using deep learning. Okay, so just to give you, most of us are using a mobile phone, right? Again, which uses the model to identify how many persons are in front of the cameras, right? Which draws the bounding boxes around the faces, where it uses the model to identify the person faces when you try to take a pictures, right? So again, nowadays models are able to run even in edge devices, which is a low spec hardware, where we'll be able to optimize the trained model and deploy it into a edge devices. Basically, it might be a hardware, or it may be a mobile phone, or it may be any GPU computations, or maybe a CPU. So it depends on kind of a hardware. We'll be able to do a quantization, or without quantizations, we'll be able to run a model. So this is one of the and the other thing which I can talk about, face recognition or a face matching. Basically, most of the electronic devices which comes with the face recognitions, right? For example, when you upload any photos in a social medias, right, it automatically able to match the person name, and then able to tag what is the name of the persons, right? So if there is a new persons where we trying to label, and then that will be considered as a training data for the model. In near futures, the same person is appeared, and then it will be able to identify what is the name of the persons, right? So if the person is not part of the training data, then it will ask you to label that person name, which is can be considered for the training data. And then in near future, any unknown samples, if you upload at the test sample, model will be able to identify, right? So, and the other thing which I can talk about, age or the gender estimations, or maybe um, a lot of other application, especially when you go into any matrimonial sites, right? It automatically identify whether the uploaded photo is a celebrity or not. For example, people are uploading the celebrity photo, where we are trying to have a model to identify whether the person is a celebrity or not, because people won't create a matrimonial site with their profiles, right? So there are a lot of ways. For example, if you write a summary about the persons, where I'm trying to estimate what will be the age, or there are multiple persons are there in uploaded photos or not. So there are a lot of mechanism has been involved to identify the fake profiles. So there are a lot of applications people are trying to use, to estimate the what are the gender or the age. So or the expression, to talk about the facial expressions, right? So Many of you are aware of the snapshot filters, right? Based on the facial expressions or the emotions, where it tries to put emojis on top of our faces, right? So which includes computer vision plus augmented reality as well. So whether it's a happy or a sad or a neutral. So there are a lot of other applications where people are trying to integrate, the facial expressions or the emotions along with the augmented reality, which means like depends on the expression, the specific emojis on top of your face can be applied. There are other scenarios which I wanted to quote. For example, Lenskart website. How many of you are aware of the Lenskart website? There will be a 3D. You don't need to go into a store where you will be able to, virtually you can sit and then it will ask you to, capture the faces and then, for example, here I'm just trying to take a photos, right? So say the light is not so clear, but I'm just taking a photo. Okay. So what happened? It will detect my faces and then the left eye and the right eye facial landmark points, and then it overlay the specs, right? So what we do in earlier days, when you want to buy something, you go into the store and then you pick the whatever the specs you want, right? So nowadays it solves most of our problem where you can do a virtually, you can feel whether it can suit for the specific person or not. There are a lot of other applications. I'll be showing some of the demonstration as well. But even e-commerce has been playing a major role. Computer vision, even if you want to see whether this kind of a color shirts can be suited for you or not. So there are a lot of other applications. Virtual makeup, for example, I wanted to purchase something lipstick, or when my wife used to purchase something, so it in a real-time camera, you will be able to see what colors you choose, and based on that color, it will show you the lip with the specific color lipstick which you have chosen. So it's not necessary, it should be an in-person, experience to purchase. But nowadays, virtually, even people are trying to see how computer vision and deep learning are. Solution is trying to help technologies in terms of for the practical scenarios. So just to give you the difference of what is the computer vision and the human, how it pursues. For example, here in terms of human being, where we have a eye, through eye it captures the objects. So my brain as the knowledge pattern, for example, I see someone where I know my brain is able to capture. For example, I know the Satish sir. I know what my brain is able to know. It has captured certain features to distinguish between one person to the other persons, right? So when it captures, brain has the knowledge pattern, which is to stay, say, whether it's a person or whether it's object is a X or Y or a Z. So my brain has the knowledge patterns, right? But how does that we are able to solve with respect to computer vision? For example, we have usually we have two phases. One is the training phase and the other one is the testing phase, right? What happens in a training phase where you will have a historical data sample. Historical data samples in the sense, let's say I wanted to categorize the 10 different objects where I wanted to perform a classifications. You get a samples of all the 10 different categories. Maybe let's say 1,000 sample for each category. So I have a 10,000 sample combining of all the 10 different categories. Then you extract some features and then you train a CNN based model, or maybe any kind of a traditional computer vision or a ML based model, or you go with the CNN. Let's say I have trained a model, CNN based model, and then I have the trained model. Okay, so here we are trying to replace human brain with the machines, where the machine has the knowledge pattern, which is called as a trained model. Okay, so now I have some unknown images which is getting captured via the IP camera, or maybe USB camera, or maybe a pipe camera, or whatever it may be. So I get some unknown images or the test images through the sensing devices, which I pass on to the machine, where my machine I have the trained model. So when I give it to the trained model will be able to categorize whether this belongs to any of the 10 categories which I have trained the model. If it is 1,000 classes, it goes to a probability score with the softmax activation function, where it is able to identify which is having a higher probability. Then my model is able to identify which class it belongs to. Okay, so here the difference is that whatever we meet someone, we introduce each others, right? We call it a knowledge pattern, which my brain is able to do. But here we'll have a separate phase called as a training phase, which is an offline phase where you collect the historical data sample, which covers all the different scenarios of your image samples, and then you train a model, right? Based on the trained model, any unknown images, if you pass on to the model will be able to identify. So this is how the difference between the human brain, how it works, and the computer vision systems. Okay, so I just thought we'll give a difference. So the eye will be replaced with the sensing device. Our brains are basically, so the computer machines are replaced with the human brain. But human brain, if I want to make a machine as a human brain, where we'll talk about the model training with the historical data samples, where you'll have a labeled data set with the different scenarios of samples. Feel free to ask your questions if anything in between, or you can post your questions in the chat. So I'll try to pick it up. Okay. In terms of the computer vision, so what are the different applications we can solve with respect to computer vision? Or either it may be a deep learning based computer vision, or maybe any traditional one. Okay. So I just put it here 3 scenarios. One is the classifications, and the other one is an object detection and the segmentation. Okay. So when I say it's an image classifications or object classifications, there are multiple objects are there. If you look at here, there are multiple objects which has the bottle, cube, and the cup. Where I have a multi-labels, my model is able to categorize bottle, cube, and cup, right? So it is able to classify what are the objects which is present within an images. Okay, so but when you go with the image classifications, it is able to give you an what are the categories of objects are there, but in which pixel regions the bottle is present, which pixel regions cup or the cube. It does not give you the bounding box regions for each of the objects. Okay, so when you go for a classification, it for the overall pixel area for the complete image regions, where model will be able to tell you this object is belongs to X or a Y or a Z, right? But it does not tell you this particular pixel coordinate is a cup or a bottle or the cube. So if I need both bounding box regions or the ROI region, region of interest for the specific objects, then I go for a object detection. Basically, the object detection will give you the bounding box coordinate for each object. Along with that, it gives the what label it belongs to. So, for example, here I have a bottle with the bounding box coordinate ROI regions, which says that this belongs to bottle. Similar way, it's for the cube and cup as well. So, for each of the objects, we are able to, along with the class labels, we are also able to get the bounding box coordinate for each of the objects, right? So, but why do you need to go for a segmentation? For example, when I draw a bounding boxes, right? What happened here when I draw a bounding boxes? There are few pixel area, still it is not a part of the objects, right? For example, when I draw a bounding boxes, what I'm trying to do, I'm trying to generate a mask. Okay, so on this bounding box coordinate, I'm trying to generate a mask. Okay, which is basically I wanted to extract the exact XY coordinate regions of each object. If I want to extract the minute areas which are belongs to bottle, then I go for a instance segmentation. Basically, the instance segmentation solves the 3 problems. One is object detection, classification, object detection, and segmentation. So, so on the each of these bounding boxes, it is also tries to extract the the exact XY coordinate regions of each object, irrespective of whether these objects are belongs to a bottle or the cube. Each of these objects we are trying to generate a mask regions. Okay, so which is basically instance segmentation. In segmentation, we have a two scenario. One is the instant segmentation, and the other one is the semantic segmentation. So when you compare the semantic segmentation, basically in semantic segmentation, we call it the pixel level semantic segmentation. There are architecture called as a unit architecture for a medical image analysis, or the segment architecture, fully convolutional neural net, FCN. So there are a lot of other architectures are available for the segmentation. The familiar one, most of the people use the unit architectures for the pixel level segmentation. Okay, so what it does in terms of pixel level segmentation, basically it tries to identify it will try to do a pixel level, it will try to categorize whether this pixel is belongs to a foreground or whether this pixel is belongs to a bottom. So for each in image classifications, you will do at a overall image level, you will try to do a classification. But when it comes to a semantic segmentation, individual pixel in an images will try to do a pixel level classifications. Each of these pixel, you identify whether this belongs to which category it belongs to. Then you try to assign a color coded value based on the predicted probability, and identify which is the maximum probability, and you have a color coded mapping value for each of the category. For example, in this case, we are trying to assign the yellow colors, which is the maximum value for this particular pixel area, whichever the yellow, and whichever the bottle regions, which is belongs to a blue color. So you will try to assign a unique colors for each of the classes. But when it comes to a instant segmentation, irrespective of whether it is a which class it belongs to, we'll assign a unique color for each object. But based on the class wise, we do a color mapping for this semantic segmentation. Especially in autonomous vehicle, when they wanted to do a road scenario understanding, many of the autonomous vehicles which uses the pixel level semantic segmentation based model. But especially when you want to see the medical image analysis, what is the area or the thickness of the diagnosis, people go for instant segmentation based analysis. It depends whether you need to, for example, any defect analysis. If you want to identify, even people go for a semantic segmentation based architecture. Depends on what kind of a model you wanted to choose, whether you want to use semantic or instant segmentation. So instant segmentation, there are mask RCNN based architecture, semantic unit, segnet, and FCN. These are the some of the state-of-the-art deep learning architectures. But when it comes to an object detection, we have YOLO architectures, and then you have a faster RCNN, you have a SSD architecture. So there is a Retina net architecture. There are a lot of other architectures as well. But these are some of the state-of-the-art model when it comes to an object detection and segmentation. Okay, so just to give you a example on the object detection, let's say I'm trying to build an ADAS system, okay, in a vehicle where I wanted to put an braking system, automatic braking system. For example, the collision detection. For example, when I'm driving a vehicle, let's say I'm driving a vehicle, there may be chances of the collisions. Okay, in front of there is a vehicle, the closer the distances are very closer, can I put a braking system? Okay, so or can I generate an alert or the alarm? So, and there are a lot of roads in understanding whatever model we try to build. For example, we are trying to identify this is the output inferences from the object detection model, which is trying to identify or detect the which are objects are there. For example, there is a traffic light and vehicles and the person. So it is able to identify the multiple objects which the models are trained to a specific object. So this is one of the example we can think of implementing for object detection. I'll show you the other examples as well. Any questions till this? When I all about computer visions are basically an image and video. Okay, so when I say an image, right, so it is represented as a 2D array, right? Okay, whether the depth will be 3 or a single channel matrix. If it is a grayscale, we'll have a single channel matrix. If it is a color images, it's a 3 channel matrix which represent the red, green, and the blue channel matrix. Let's say I have an handwritten digits, okay, which is the pixel dimension of 18 cross 18, which I have represented 18 cross 18, 18 rows and 18 columns. Whichever the pixel areas which are belongs to the foreground. If you look at here, wherever you see the pixels areas which are more than 50, which are belongs to the digit 8, whichever the background, okay, which are 0 or maybe closer to 10 or 50. But where you see the regions which are belongs to the handwritten digit, which are having a high intensity value, but whichever the background which is a 0. So basically here, how we perceive an images, but the machine representation will be a 2D array with a certain pixel value. But the machine representation will be a 2D array with numerical values between 0 to 255. But the human representation of images will be visually how we perceive. But the machine representation will be that is how the machine sees as some numbers with the matrix, right? Do you think all these pixels values are static? Let's say I'm writing an handwritten digit, something like this, right? But the machine representations will be like each person will write in a different style, right? Someone is writing like this, someone will write like this. So I can't expect the pixel positions. We can't expect this pixel position will be the same value for all of the images, right? So that is another challenges when you represent images in a matrix. The pixel intensities are not a static. Okay, the pixel intensity might change with respect to multiple scenarios like the lighting conditions, the orientations, and the occlusion and the scale. There are a lot of other, scenarios where your pixel intensity might change, right? How model will be able to recognize, that is where comes where you need to collect multiple samples. Let's say I wanted to build an image classifications model where the classifications model is a binary classification, which means that the given image is a handwritten digit 8 or not. Okay. So in classifications, we have a two category. One is the multi classifications and the binary classifications. In terms of multi classifications, when you have a more than one category in your target variables or in your training data set, how many unique categories are there? So it depends on if you have a more than one category, then we call it as multi classifications. In this case, I'm trying to build a true or a false scenario, which is the true is the digit 8. Other than digit 8 will be a negative scenarios. So here we are trying to build a deep learning based model. Let's say I have a training data set with a different person's handwritten digit 8. And other than the negative scenario will be, other than digit 8 will be a negative scenarios. Okay, so I have a labels which are belongs to a handwritten digit 8 will be a 1, other than digit 8 will be 0. So these are the binary labels. One is belongs to a handwritten digit 8 and the other than handwritten digit 8 will be 0. So this will be fed into any CNN based model, or you can also try to solve with the deep neural network. Okay, so the beauty of CNN will be it will have a feature map extraction followed by a classifications hidden layers. But when you don't use a CNN, the blind deep neural network, it only performs the classifications because it does not extract any feature map from your raw data. Okay. So now let's say I have a input layer. When it comes to a deep learning, you will have an input and then you will have a hidden layers and output layer. Input layers, since I have a 18 cross 18 as an input dimension, so there are 324 nodes are required. Each of these nodes are one of the pixel value. For example, here you have a 0, 0 pixel 0. So each of this pixel value will be a one. Each pixel will be a one node in the neural networks or the deep learning input layer. Each of these node will be a one pixel intensity value, and then you pass on to a subsequent hidden layers. You create a two or a three hidden layers, and then the output layer with the single node where you use a sigmoid activation function, which gives the labels of 0 or 1 based on the probability score. So we'll get a probability scores between 0 to 1, and you have a decision boundary or the threshold, and then you categorize if you get a probability score at the output layer of 0.6 or a 7 as your threshold or the decision boundary, and then you categorize as a digit 8. Other than probability scores of less than threshold, then we categorize as a 0. So that is how you do a feed forward propagations and the backward propagations with respect to a loss function. So where you use a cross entropy loss function, and then you compute a the binary cross entropy loss, and then you do a backward propagations. Basically, you use a gradient descent with the weight optimization technique. So we'll have a random weight vectors, and based on the loss or the error calculations, you do a back propagations. So you'll have a feed forward network and the backward propagation. So this happens for a multiple epochs or the iterations until you get the convergence of 0. So we'll be training our models to reach your loss or the error rate or your convergence, which comes to your error rate closer to 0. So let's say I have some problems. Okay, let's say I have some problem statement, which is basically to identify whether the persons are wearing a face mask or not. Okay, this is the problem statement. Okay, assuming you have a problems, what are the steps or what needs to be done to build an end-to-end pipeline to create any computer vision related solutions? Okay, so now I have a data set which is having a person with face mask and without face mask, where I have a combination of all the genders and the different age groups and the different types of colors of face mask. So make sure your training data covers all the diversity scenarios. Okay, diversity in the sense uh, for this specific problem, gender is the one diversity, and the different regions maybe a Asian or maybe a because each of the person faces skin tone might look different, right? So and the different genders, different age group. Okay, so and different face mask. So make sure you all of the scenarios are covered as part of your data set. Once you have your data set, and then you split your data set into a train test. Okay, so you split your data set 80% into a model training, remaining 20% as a testing. And then you build a model training and the training data where you do a feature extraction with the CNN based architectures where you do a feature map and the model training. And then you use the test data, test data to validate your models, right? So because we can't use the same training and the testing as the same data, because always we need to see how model behaves on the unknown data. So you split your data set with the ratio of 80-20 or a 70-30. So the more samples has to be used for model training. So once you have the trained model, pass on the test data and validate your so there are different metrics you can use for the model evaluation. One of the metrics are a precision or the recall for the classifications problem. If it is object detection, we use an IOU score, which is an intersection over union. And if it is a segmentation, there is a different problems. Okay, so once you have your model evaluations, here we'll also use a confusion matrix, basically where you will have an actual value and the predicted labels, and then you say true positive. So when your predictions and actual ground truth are the same, we call it a true positive scenario. Let's say person is wearing a mask, my model is also saying a person wearing a mask, which is the true positive. And the other scenario, which will be a false positive, there is no person is not wearing a mask, but my model is says that person is wearing a mask, which is basically a false positive. And false negative is something where person is wearing a mask, but my model is saying a person is not wearing a mask, which is basically a false negative. And the true negative will be a person is not wearing a mask. My model is also saying a person is not wearing a mask, so which is a true negative. Based on this true positive and false positive, false negative, and true negative, you'll be able to compute the metrics of precision and the recall. So, which is basically true positive divided by so false positive plus true negative, and then you will have a precision and the recall value to compute. In terms of the precision and the recall. So why do you need a feature map extraction? Because I spoken about the pixel intensities are enhanced static, right? For example, you capture a texture features, or you capture a color features, or maybe a key point features. So it is a the feature extractions plays a major role where you convert your raw data into a high dimensional space and then extracted features you do a neural networks or maybe use an ML classifier to perform an classification. Any questions till this?
Sir, can you please repeat intersection over union alone? IOU.
Maybe I'll show you that. So this is basically an IOU score is a metrics. We use it for object detection model. Okay. The red color one is the actual bounding boxes, which says that which is manually created bounding boxes as a ground truth. And the purple one is the bounding box, which is identified by the model. So first you identify the intersection, which is in which is the numerator. The denominator will be the union of both the bounding boxes area will be the denominator. Numerator will be the intersection point. So how do I say IOU score? Basically, you compute when I say it's a true, can I consider this as a true prediction of object detection? Set a threshold, let's say above 0.5 or 6 of IOU scores, or we can consider as a true predictions. Then we can consider this as a basically the true objects is present. But if you are having a less than 0.5 or a less than 0.4, then we can't consider this as a, so where you are overlapping is having a lesser IOU score, which we can't consider as a true prediction set also. If it makes sense.
Clear, sir. Thank you, sir.
Any other questions? Okay, maybe quickly I'll show you a couple of demo. I'll start with the different applications which I've worked on. Okay, so one of the use case which I worked on the smart parking system where I've used a YOLO based architecture object detection model. It's a custom YOLO object detection model which identify the car and the number plates and the two-wheelers. So where I've trained a model which can identify car regions as well as the number plates area. Along with that, I've also used a OCRing technique. After you detect the number plates regions, it also extract the characters of the number plates. And then see, it's basically to validate or to authorize. For example, we have a fast tag system, right, where you have a RFID which is placed in the reader will be there. It reads automatically and then it detects the money, right? For example, can you use a computer vision based systems to extract the number plates and then match? Let's say I have an employee metadata with the number plates information. Whether can I authorize this number plates are getting matched, and also we'll be able to know how many parking slots are available based on the entry and the exist. If you have a multiple cameras entry and exist, and based on that you can have many shopping malls they use no sensors, right? Based on the sensors, it identify whether there is a parking available in the particular floors or the, but still the sensor sometimes it fails, right? But can be replaced no computer vision based system based on the still there are challenges are there with the different smaller scales which is not following the standard government number plate. So it has their own challenges, but this is one of the problems which I worked on in terms of identifying the vehicles and then extracting the number plates from the vehicle basically. So which has been trained on the YOLO based deep learning architectures to detect and to extract the number plates information. Okay, so moving on, so this is the how it works in terms of, so you have a VM, okay, which is a virtual machine, which has the API connectivity between all of these three gates, which is exist or entry, and then it sends the informations to the VM, which is the posted, and then you send the informations, and based on the entry and the exit, you have a even you can use Jetson devices as well. There are NVIDIA hardwares are available where you don't need to deploy your solutions into a REST API services into a cloud. Instead, you can host your deep learning model within the edge itself. Jetson Nano, Jetson TX2, Jetson Xavier, depends on how complexity or how many cameras are connected to your hardware. So you can choose the specific kind of devices to run your deep learning model within the edge itself, instead of hosting your deep learning model into the cloud or somewhere your own private data centers. Okay, so another thing which I wanted to talk about, basically, when you go into any informations, right, whether it may be a ID card or it may be a any KYC informations, right? Let's say you submit your document, KYC documents for the account opening, right? Let's say I wanted to open a salary account, so I provide a salary slip, and then I provide a KYC for the address proof I submit, right? So you give some you fill some informations in the portal, and then you submit a proof, right? So what happens here nowadays? Earlier days, if you think of maybe 3-4 years back, the account opening time, which takes maybe a lot of time, it might take, but nowadays even within a 15 minutes the accounts are getting created automatically, right? So whether it may be an invoice document or it may be any account opening or maybe any invoice you submit for the documents, right? So there are multiple OCRing techniques has been used. Let's say this is going to be the invoice where I'm trying to identify the text regions around the invoices or the documents or the payslip or whatever it may be. And then once you extract the text, right, from this text, you extract the features for each of this text, and then you use a NLP based method, which is an entity extraction, based, the NAR based named entity recognition, which means you try to label whether this text region is in invoice number or a date or an amount, or whether it's a GST number or whether it's a VAT number or whether it's an address. So use some kind of a NAR based model which is able to identify out of all this text where I wanted to extract the specific area or the specific regions of text which are my own interest, right? Now, earlier days, there will be a data entry process. What happens in a data entry where the human being opens the documents and then they do a data entry, right? So nowadays, a lot of automations has been done when it comes to the document automations, right? And even if I consider a check, right, when you go and deposit a check, what happens? Other bank checks, what happens? It goes. Let's say I have a HDFC bank. I'm going depositing HDFC checks in an SBI. The SBI, what happens? They take a 2-3 days SLA, right? Why that 2 to 3 days SLA? From the SBI, they send the scanned images to RBI. From the RBI, it goes to a issuing bank, which is the HDFC. So what happened in my previous role, I worked in a finance industry, one of the MNC banking. So what happened when it comes to a banking system, we have an scanned images. So we use an OCR to extract the account number and then to extract the amount and to extract the date and then extract the signatures. And then you verify all this signature verification and the data extraction. and whatever they are getting from the information scanned images, all these are automated nowadays. So the check, even the check clearing is some of the markets we have end-to-end automated. So especially the intelligent document processing has been plays a key role in, especially in the banking industry. A lot of automations has been done with respect to one intelligent document processing. So whether it may be a multiple languages or it may be a no English, or there are a lot of things are happening. And also what happens, one of the use case which I worked on, especially there are some high profile customers will be there. Like let's say we have a Stalin or maybe some corporate with a high profile client, we do an adverse media search. For example, in a social media, is there any criminal offense or a tax aviations, or so we do a web scraping from the Google images and we identify the sentiment analysis on the client name from the web scraping content, and then we also do a summarization, text summarization from the web scraping content. So there are a lot of automations across multiple industry. You can try to see whether what kind of solutions it can be used. So now coming to one safety detections, right? I'll pause here. Any questions? No questions? Okay. So now coming to a safety detections, right? Which is basically a personal protective equipment, right? Which means the personal protective equipment, maybe what do I say? In a manufacturing industry, when you go into a manufacturing area, especially in automotive, so we have a painting shop, body shop, and engine and chassis. There are different sections are there. Each of the section area, the PPE is must. Okay, depends on the goggles or the safety helmet, safety shoes is must for all the area. But depends on the different section. They use the goggles or the gloves. So depends on the multiple area. There are restricted zone as well, where there will be robotic robots will be run, will be arms will be running, but a person entry to that area is restricted. So especially this wearable of all these personal protective equipment is must to enter into the specific area. So is there any 100% validation happens? If you ask me, there is nobody is validating. There is a safety engineers, but they goes randomly and they checks whether employees are following the safety guidelines, right? But uh, can we do an 100% validation against the safety guidelines? The answer is yes. But there are some existing CCTV cameras are available. Can I use those input video feed on top of that? Can I apply some object detection model which can detect the person with helmet, person with a vest and the safety shoes and other things? Okay, so these are the some of the model we tested, whether the person with helmet and without helmet and wearing and vest, and the so you think of whether which are the objects needs to be you define what is your target objects which needs to be weared by the persons. Okay, so this scenario which I've created the data set with the vest and helmet, and the person is not wearing an helmet. Okay, so and generate an alert or saying this particular phase the person's is not wearing a helmet. Okay, so we can create the specific number of categories of objects, and then you train any object detection model. So okay, so another thing which we have done, maybe I'll run this demo. Okay, so the person is wearing a smart glasses, which is an U6 AR smart glasses. The object detection is running within the smart glasses. So we created an quality inspection. Maybe you just watch this video. Maybe I'll summarize. Okay, so what happens here? We do a quality inspection is one of the checks. Whatever the vehicle, any kind of a manufacturing product, there will be a final phase which is called as the quality inspections, right? So, especially for the vehicles, we have a checklist, whether it's the interior or the exterior, where there will be an SME who validate all these checks manually, and then they verifies whether it satisfies all the quality inspections, right? Can we automate because someone who is not having an knowledge of about the vehicles, can he do the quality checks? The answer is no. But now what we have done, we have tried a model, with respect to a different regions where we are trying to detect the multiple object regions, and then we capture what are the objects are there with the alloy wheel, fog lamp, and the different object region, and we verify whether that quality inspection against that particular chassis number or the vehicle number is satisfied. Okay, so if the person can bear the specs and then he can walk around all the sites and the interior and the exterior, and then the quality inspection will happen automatically. So these are the multiple quality inspections can happen. Okay, so for example, even in a semiconductor industry, right, where there will be a chip manufacturings are happening, so there will be a lot of wafers will be there, dies and wafers. So where we are trying to do a quality inspections or the defect analysis, from the scanning of the die or the wafer images, and can we identify is there any defects in the chip which is getting manufactured? So there are a lot of other scenario where the quality inspection can identify. Even any recent days, the insurance company, right? They also validate what is the depth of the accident is happen based on the claim amount or the claim is getting approved. So they also do a lot of online based the object detections or the vehicle insurance claiming is also happening. So maybe I'll show some of the demos. Any questions? So it is trying to detect and identify whether the person is neutral or sad or whether he is happy. So this particular model is trying for it. No, it says sad, but maybe the lighting is one of the reason. Earlier it was saying many times it was saying a sad, but it depends again. So it is able to detect the face regions, and then it is able to categorize the model into any of the 7 categories of emotion. So basically here you can think of integrating the facial expressions or the recognition with respect to the snapshot filters and a lot of other use cases which we can think of integrating the facial expression recognition. This is in real-time object detection. It can detect a person, it can detect a chair, this can detect a person, chair, it can also detect, let's say, it can also detect as a mobile phone. So this is a particular model which is trained on, it can also detect as a chair. Um, so this particular model is trained on Microsoft Cocoa dataset, which has the 80 plus classes, and you can make use of no, the pre-trained models. Basically, here this is the pre-trained model for the object detection. This particular model is trained on 80 plus classes for the Microsoft Cocoa dataset. YOLO object detection model basically. So the YOLO is a you only look once object detection model with respect to SSD YOLO and the faster RCNN. So there are a couple of other models, but the one I showed with the object detection, which I'm using YOLO pre-trained model with the COCO dataset. So if you want to see what are those labels, you can see the list of classes which is specifically the model was trained on actually. So these are the 80 classes which these models are trained. So we can use YOLO V3, which I'm whatever I've shown. So till V10 are there, YOLO versions. The one I showed with the YOLO V3, with the pre-trained model for the object detection. Any questions? Any questions? So I'll show you the one which I wanted to show. There is an face, once it detects the face, it identify whether the person is wearing an face mask or not. So basically, it say whether the person with mask or the without mask. But so you can once you detect the faces, and after we detect the faces, it is able to say whether the person is wearing a face mask or not. So you build a classifications model on the crop detected face regions, and then we classify whether the person is with mask or without mask. So you can build an your own classifications model on top of the detected faces. So after face detections, we are trying to build an face mask classifications on the cropped face ROI regions. Okay, so you can do a expression recognitions or you can do a face mask classification. So basically here I had a data set with the mask, okay, and then without mask. So this specifically trained data set for the face mask classifications on top of the detected faces. So here we used SSD based mobile net architecture, mobile net SSD architectures for the face detection model, and the detected faces we perform a face mask classifications basically. So another one which I thought I'll show you this as well. Okay. Let me show you this one. So, basically a face recognition one, it identified, and also along with that, we are also getting an facial landmark points from the faces. Okay. let's say I have some of the photos which is a recorded captured images. Okay, so let's say I have some captured images which I'm trying to show here. Sometimes it detects. You're able to see sometimes it detects, right? Even the person is not in front of the camera, but what happens, it is able to, you are able to see, even from the, it's basically a spoofing attack. Even I have let's say the photos are, if you have the persons, where your face is unlocked, let's say you have enabled the face biometric. If it is, if I have your phone with your photos, then sometimes what happens, it is able to unlock your phone, right? That is where comes the depth sensor, where the depth sensors, it is also able to identify and say whether the person is really alive or not. So there is a face liveliness system which validates whether the person is really in front of the camera, or they are using some recorded photos or a recorded video, so which can identify whether the person is a real or whether it's a fake images. Okay, so we can validate one more steps, pre-validation, before you do a face biometric verification. Validate whether the person is really in front of the cameras or not. So, for example, if I wear a 3D mask of Modi or some persons, right? It should not say the person is a Modi or a XYZ, right? So, we should have some way to identify whether it's a fake or the real images. So it says that it's a real images, right? Let's say I'm showing a photo. Let's say I'm showing some images from the photos. Okay, so it's saying it is a fake one. So there should be some way where you should have a mechanism to detect whether it's a real images or the fake, whichever showing from the captured images. So I worked on some of the work on distinguish between the captured real images and the recaptured images, which are the fake images. So you can use. I have tried with the handcrafted features, the traditional computer vision. But recently there are deep learning approaches. You are heard of deep fake, right? Even you are not attending a meeting, someone is attending, but virtually what you see, the person X and Y or Z is attending. So there are deep fake technologies are grown up now, but you should have some way to detect whether that is a real or the fake persons actually. So. Okay, this is another one which. So what happens here? It detects the different facial landmarks, right? I think I've shown you the lens card, how it works, right? It uses the facial landmarks for the given and input image. It identifies the left eye and the right eye, and then so even I have spoken about the virtual, virtually if you are purchasing something lipstick, right? So from this lip, the landmark coordinates, whatever color we choose, it applies on our lip and then it shows an output, right? How many of you have seen the Reface app where it can face swapping or a reface? There is an app called an face swap, right? So let me show you that. It is also uses this facial landmark coordinate. Let me show you that. Okay, so now what I'm going to do, I have two images, which is a Hillary Clinton, okay, and then I'm going to have a Trump one, okay. So these two images, I'm going to do a face swapping, okay. So let's do. So now each of these face, I'm going to detect the jaw points, which is the facial landmark points for both image one and image two, and then I'm going to do a face swapping. Okay, so now what happens here? This is the face swapped images. Okay, so now what happened? The actual image will be a Trump, but the face regions which have cropped it from the Hillary Clinton, the regions which have replaced onto the basically the Trump images. So which is basically be used on the facial landmark coordinate for both the images and the regions which is getting fixed onto this particular. You can also do a vice versa as well. Let's say what I'm going to do, I'm going to pick this one as a, so now on Hillary Clinton images, what I'm going to do, I'm going to replace the Trump images. Okay, so now what happened here? If we look at here, what is happening here now? So actual image will be Hillary Clinton. So the Trump, the face jaw regions. So here we are using the facial landmark coordinates, which I have the facial landmark coordinates points for. There is a 68 facial XY coordinates are there. So which I've shown the earlier demo, right? It uses this 68 facial landmark coordinates on the each of these face images, and then it applies the face swapping mechanism. So there are apps are available where you can take any Bahubali or any movies where you want to replace the hero or actor's face with your own face. There are a lot of apps are there we can generate it. So it uses such a technologies, methods to identify or crop and replace the person face with the X or Y, Z faces. Any questions? I'll pass it here. Okay. This is another.
Any questions from participants?
This is another object detection model which I've created. This for the bison. Actually, what happened? My guide was in Kodaikanal. She was a VC for the, Mother Teresa University. She was asking me if I can come up with the bison detection model. So which I've created. I've trained a custom object detection, YOLO object detection model. Even I've deployed this into a Jetson devices. From the Jetson device, it also connected with the IP camera, and then it is able to. So whatever I'm showing, it's not a live demonstration, but from the recorded video stream, we are trying to see whether the bison. So I've trained a set of sample with the bisons, and then I've trained a model. If you give any videos or the input source videos, live or the recorded stream, it will be able to detect if there are bison is present. Okay, so especially, so can we? It might be a bison, or it may be elephant, or you can think of any objects. You can create your own custom object detection model. Where you need to create a ground truth for your training data set with the bounding boxes coordinate, there are a lot of tools are available to create a ground truth for the object detection. So I'll show you the tool which can be used. So this is another object detection model, custom object detection model, which I've created to detect if there is any bison in the input video stream which is deployed somewhere. This can be in any object, but this is a scenario which is tested for the created specific to a bison detection model. For example, let's say you want to create a ground truth for your object detection model. So you can use a label IMG tool. Okay, so let's say I have a data set. Let's say I have images where I wanted to do a ground truth. Okay, so this is a tool which you can use to create a ground truth. So you can manually, you need to mark and say this object is a vehicle or a car. So whatever, you can create your own ground truth. Okay, so you can use this particular tool. The tool name called as a label IMG tool, where you can create your own object detection ground truth. So especially when you want to create a custom object detection model, or you can also use a label studio. Either you go for a label studio or a label IMG. Okay, so these are the especially when you want to prepare a ground truth for your training data, whether it's a video or a text or whether it's audio. This is a open source tool we use in industry to create a ground truth actually. So you can use label studio or you can use an label IMG. So these are the label IMG specific to a image annotation tool. But when you go for a label studio, it's a cross functional data. So either a text or a video or an image or audio data. So I have one or more demos. Let me complete that. So this is basically a person detection. Again, it uses the object detection, pre-trained object detection model. From the object detection, only I'm focusing on the person categories alone. Whichever the object detection says that the bounding box regions with the person. For each of these bounding boxes regions, we are trying to identify the center point for the bounding boxes. For each of these bounding box region center point, we are trying to do a distance calculation, the pairwise distance calculation among all the bounding boxes, and whichever are very closer to the threshold, we say it is a very close social distancing, or maybe you can think of any parameters. But we are trying to see whoever very congested or very closer to each others are represented in a red color bounding boxes. Whichever are following the some distances with the threshold, which are in a green color bounding boxes. It's basically a social distancing kind of a scenarios. We thought can be a identify persons, and within the persons compute a centroid for the bounding boxes and do a distance calculations between each centroid with the other bounding boxes centroid. So This is another input video stream. Okay, this is another example where we do a person detection plus tracking as well. Where we do a person and we do also tracking, right? I wanted to see how many people are visited my stores or how many people entry and exist, and I wanted to see that there is a virtual line we created, and then we also track how many people entry and exit. So I use the same person detection model, but from the person detection model, we do a tracking as well. Once we identify the person, we also track until he goes out of the frames, right? So for each of the persons, we put a unique ID and whether they are entry or whether they are exist. So we do a person object detection plus tracking as well. So you can think of a multiple scenarios of, especially we have a motion sensors, like in people try to see how many people are entry and exist, right? So can we replace with the computer vision based system to know how many people stats about the stores which they have visited, right? So there can be an, multiple applications as well. So I have one more. With that, probably I'll park for a questions. So this is an multi-view face detections, right? Whatever the earlier one I showed, right? It may not work well when you have when you rotate your face or when you tilt your face. It may not be able to detect your face as well. Right? So this is an deep learning based detect if you tilt your face or if you even your face regions are very smaller, especially when your faces are in a crowded scenario. If you are detect the person faces, it will be able to efficiently detect the person faces. So this is one of the deep learning, but it's a computationally expensive model. It may not work well if you run it on the low spec hardware. So you need a GPU computations, especially to to detect the person faces on such a models actually. I'm pretty much done, so maybe I'll park for 5-10 minutes for the QA. Based on that, probably I'll answer the questions. I'm audible?
Yes, sir. You are audible, sir. You are audible. Participant side, any questions from your side, please post your queries, raise your queries. I think Mohanraj sir, no questions from participant side.
Sir, one question, sir. In
What
bison
is the
detection,
text you want used to evaluate the text data are strictly optimized for image. See, text is basically you can also go for especially for the text recognition. We use a word level or a character level error rate. But for the localization point of view, you can use an IOU scores actually. So depends on whether text recognition we go for a word level or a character level error rate. For a bounding box, still you go with the IOU scores actually. So 51 we use to evaluate the text limits. I don't know how can we use a code mixing language algorithm, find a slot or intent. How can we use the code mixing language? No, I didn't get to your questions. Maybe you can unmute, you can ask your questions. I'm not able to. Not sure. Intent detection.
Anita ma'am, you can ask your queries. Anita ma'am.
yes, ma'am. Sir, in bison detection video, actually there are frames where each and every frame is not detected properly, right? So is there some possibility like if we run the video and we can take just one image which is of good quality? Is there some way for determining one
What you
frame
can
of good quality?
see the way this I've taken from the YouTube video. What you can do, you can use a keyframe extractions, right? But we can't go with the frame selections, right? See, either you go for a keyframe extractions, or you do a object detection plus tracking, right? So that is the best way, but you can't judge the quality, right? See, in a real-time scenario, especially if you want to do a real-time object detection, we can't take a one single frame and do object detection. So that there may be a false detection as well, right? So better to know take a continuous. Maybe I suggest not with a single frame, but go with the continuous 5 or a 10 frame and then generate an algorithm. So with one single frame, if you decide, there may be chances of false detections as well. So
Yes, sir. But if is there some method like where I have a video and I have continuous frames and I need to detect some 10 objects continuously, but each and every frame, if we evaluate, there is a possibility that one object may not be captured well and it may be
that is true.
hazy. So is there
See,
some way like I can determine the best frame uh, out of the frames and then perform.
no, that may not be possible, right? Let's say in object in a frame one, there may be an additional object. In frame two, that additional object may not be there, right? So again, it depends on how visually your object is visible to the model, right? Let's say one of the scenario might be a like occlusion will be one of the scenario, or the blurriness or the quality of the images, or the lighting conditions, or the orientations, right? So there are several factors. We can't decide this is a frame where we can pass on to the model. That is where keyframe extraction. But the keyframe extractions will be like when the objects are static, when between a nth frame and n plus 5 or n plus 2, it is not necessary to feed, because in a second you will get a 25 frame. Not necessary every frame has to be fed into the model, right? So that is where a keyframe extraction plays a role. You can use a keyframe extraction algorithm to identify, instead of sending all the continuous frames from the live stream, you can do a keyframe extractions, and from the keyframes alone, you can pass into the model inferences.
Okay, sir. Okay, sir. Thank you, sir.
Any other
Hello.
questions from participant side?
Hello. Ma'am.
Yes.
Hello.
Yes, go ahead, sir.
Yes, sir. You can
Uh,
go ahead. Go ahead.
yes. In my question is in NLU. If I have to find a slot or